do the construction of simplex table, which is called iteration table 1. How do you get that? Put the values. Looking at our table, we have 2, 5, 1, 0, 24. No, 2, 5, 1, 0. These are our values. 4, 2, 0, 1. So this is the nature of the equation, whereby B is S1 and S2. CP is our core value is 0, 0. Then we have XB, which is actually the constraints. We have 120 and 80 days. Now we do the calculation. You say 120 times 2 plus 80 times 4, you get 0. No. 0 times 2 plus 0 times 4 is 0. 0 times 5 plus 0 times 2 is 0. 0 times 1 plus 0 times 0 is 0. 0 times 0 plus 0 times 1 is 0. So when you add this, you get 0. So Zj is 0. Zj, which is now the coefficient variable of our objective, 3, 4. Now what you do, you say 0 minus 3 is negative 3. 0 minus 4 is negative 4. Now, we said we need to actually establish what we call incoming variables. So how do you get the incoming variables? You take the highest non-negative. Our highest non-negative is negative 4. So this will actually establish our incoming variable. So x2 is what we call incoming variable or incoming vector. Now, how do you get the outgoing vector? Outgoing vector, you find the minimum value or the minimum ratio. To get that, take the key column, which is 5 and 2. So key column for the first equation in the row, 120 divided by 5 gives you 24, which is the ratio. 80 divided by 2 is 40. So in our R, we take the least value. The least value determines the outgoing variable or outgoing vector. So 24 is our outgoing vector. So that gives us the value. So already we have determined the incoming vector is x2 and the outgoing vector is s1. Now how do you get that? To get the solution, computing the new value of the incoming vector formula, the old value of the key row you divide by the key element. So in our equation, S1 is 122, 5, 1, 0. Divide by 5. The values that you get is 24, 2 over 5, 1 divided by 5 is 1 over 5, 0 divided by 5 is 0. So the value of x2 is that. The value for S2, how do you get that formula? The all values of the row less the new value of the incoming vector multiplied by the value in the key column. Now this is how you come up with. S2 is 80, 4, 2, 0, 1. These are the old values. Minus 2 in bracket 24, the new value, which is 24, 2, 5, 1, 1 over 5 and 0. So negative 2 over 5, 80 minus negative 80, negative 48. You get 32. 4 minus 2 over 5, you get 16 over 5. 2 minus negative 2, you get 0. 0 minus negative 1 over 5, you get negative 1 over 5. 1 minus 0 is 1. So the new value for S2 is 32, 16 over 5, 0, negative 5, and now we come to the next table, simplex table 2. Now in our simplex table 2, again we restart the process. 4 times 2 over 5 plus 0 times 16 over 5, you get it is 8 over 5. 4 times 1 plus 0 times 0, which is 4. 4 times 1 over 5 plus 0 times negative 2 over 5, you get negative 2 over, you get 1. 4 times 0, which is 0. 0 times 1, which is 0. You get 0. Now, you get what we call net evaluation. Now, our net evaluation is 8 over 5 minus 3 is negative 7 over 5. 4 minus 4 is 0. 1 minus 0 is 4 over 5. So I think there is a problem. It's supposed to be 4 over 5. 0, 0, which is 0. Now we come to the determining. So our incoming variable is x1. How do we get the outgoing variable? Use the key column. This is our key column. You say 60. No, you say 24 divided by 2 over 5 gives us 60. 32 divided by 16 over 5 gives us 10. Now, solution for that. The all values of the key column divided by the key element. So S2 is 32, 16 over 5, 0, negative 5. Now, when you divide, we get 10, 1, 0, negative 1 over 8, 5 over 6. The values of x2, how do you get that? The old values of the row less the new values of the incoming vector multiplied by the key column. So these are the old values, x2. The new values will be 24 minus 2 over 5, so it will be a half, which is giving us 20. 2 over 5 minus half. So 2 over 5 minus 2 over 5, 0. Again, you say 1 minus 0 is 1. Again, you come and say 1 over 5 minus negative 1 over 8, you get 1 over 4. 0 minus 2, it is negative 1 over 8 when you do your calculation. So our new iteration table or simplex table will have these values. Again, you start the process. 4 times 0 plus 3 times 1 is 3. 4 times 1 is 4. 3 times 0 is 0. So you get 4. 4 times 1 over 4 plus 3 times negative 1, you get 5 over 8 all the way. So the values of zj is 3, 4, 5 over 8, 7 over 16. Now what you do, you subtract. You get what we call, we get the net evaluation. So our net evaluation is 3 minus 3, 0, 4 minus 4, 0, 5 over 8 minus 0, which is 4 over 5, 7 over 16 minus 0 is 7 over 16. Now, when you look at the net evaluation, there is no negative. If it is non-negative, we have reached our optimum value. So our optimal solution, the net change is non-negative, which is giving us the maximum profit, whereby x1 is 10, which is this, x1 is 10, and x2 is 60, which is this. So our maximization is the maximum product can be produced when x1 is 10 and x2 is 60. Now assignment, work on this assignment, get the solution, send it to me. Thank you so much for your listenability. See you in the next area.